In this video here, I'm going to talk about light, a little bit about its history in physics. Galileo, back in the time, uh, wanted to measure mass. I don't know if he was the original inventor, I guess, of what mass is as particles. But in his era, he couldn't do it. He said it was too small. And it wasn't until 1915 that Albert Einstein uh, caught up on that and knew the history about what mass was and developed his theory. I don't think Einstein gave Galileo credit for that. I know he researched the information and created his special and general theory of relativity. What if gravity didn't just bend space? It carried you. Picture this. Space isn't a stage, it's a moving walkway. In the carrier gravity idea, a planet, a star, a galaxy is already surfing the universe's expansion. If I link my ship to that motion, like drafting behind a semi, I get the slipstream. Locally, I can ride up to Lightspeed. But because my carrier, the expanse, is also moving, my total velocity relative to where I started can stack 2c even more without breaking my local speed limit. Here's the twist, the math. Standard physics says kinetic energy scales with v squared. Double speed, pay 4 times the energy. That's the wall. But in expanse physics, I treat it as E equals mv to the first power. Linear, double the speed, double the energy. That lines up with a 2-to-1 space-expanse ratio. 1 unit of energy to neutralize the mass's grip, 1 unit to propel. And the expanding universe carries the rest. And this isn't about pulling speed from nowhere, it's geodesic following. Galaxies already fly along the fabric of expansion. I'm not inventing momentum, I'm hooking into the cosmological current. Under this lens, the famous E equals mc squared isn't a tax that bloats my mass. It's banked as propulsion potential when ship and expanse move together. Contrast that with rockets. The 1-to-1 energy trap says to push 1 pound a ship, I need fuel that weighs a pound. Now the ship weighs 2, so I add more fuel, which weighs more, so I add more fuel, and the spiral explodes. Even with weightless push, say a laser sail, I hit the Einstein wall. Pour energy into a 1-pound craft at 90% light speed and it behaves like 2.3 pounds. My push stays the same. The effective mass grows. Acceleration starves. So what breaks the deadlock? Massless propulsion in 2 flavors. First, the D-linked model. I unplug the ship from the Higgs stickiness. Think of the microcosm like molasses. With the link severed, inertia's grip is gone. Even a whisper of energy nudges me because I'm not dragging the field with me. Second, the anchor model. I don't shove the ship through space, I pull space toward the ship. I spend my 2 units of energy not on pushing matter, but on contracting the field ahead. Move the molasses. Don't swim through it. This reframes the 2-to-1 rule. Pound 1, cancel the static grip, inertia. Symmetry, the baseline hold of the Higgs field. Pound 2, produce motion. At high speeds, standard physics doubles down, demanding more than 2-to-1.